Hey everyone, so today we're going to be learning about Julia, which is a relatively new programming language that has been quickly gaining popularity because of its combination of ease of use and powerful processing speeds. Julia is still in its infancy compared to other more mainstream languages like R or Python, but its functionality is improving quickly with time. So the first step in learning Julia is obviously going to be downloading Julia in a format that is easy to use. There are several versions of Julia that you can install based on your needs and personal preferences. The first version that you can download is just the base Julia language. This version of Julia is free and open source. You can find this version by going to julialang.org/downloads. There are different versions of Julia based on your operating system. There's one for Windows, Mac, and Linux, but they're all functionally the same. Since I'm using a computer running Windows 10 right now, I would personally go with the 64-bit Windows version. This is a pretty small download, and it should finish pretty quickly. The installation process is pretty straightforward as well. In addition to the base Julia language, you can also run Julia on a platform called Juno, which is built on the Atom editor. The advantage of working through Juno is that the UI is in general much easier in the eyes, as well as more customizable, so that you can have, for instance, your plots and your other outputs in separate windows, or to create key bindings. You can download Juno by following the fairly simple installation instructions at junolab.org. I'll be using Juno later on in this video to present some code. The second version that you can download is called Julia Pro. You can find it by going to juliacomputing.com/products/JuliaPro. Julia Pro includes the base Julia as well as a bunch of extras. The most important difference is that Julia Pro comes with a lot of packages already installed in it, whereas with the base Julia installation we just saw, you would have to individually load whichever packages you wanted as you needed them for whatever you're programming. These packages greatly increase the functionality of Julia in terms of the statistical analysis and visualization methods it is able to use. This makes Julia Pro more convenient and generally easier to use. Julia Pro also has other stuff like a debugger, integration with Jupyter, which we'll talk about in a bit, and more support for plotting and machine learning because of the included packages. When you go to the site, you'll see that there's another version of Julia Pro called Julia Pro Enterprise. Most notably, the Enterprise version has integration with Excel, which means that you are able to access Julia and its functions from Excel. Now, since I'm a poor graduate student and the Enterprise version costs $1,500, I've only ever personally used the free version, but that has more than enough functionality for the average person. Julia Pro is a much bigger download than the normal Julia download, about 500 megabytes in size, but the installation process is more or less the same as with the base Julia version. The last version of Julia that you can use is called Julia Box. It doesn't require any download or installation. It actually works right in the browser. You can access Julia Box by going to juliabox.com. Julia Box works by integrating with the Jupyter Notebook interface. Jupyter is an open source web application that allows you to code directly within your web browser in a variety of languages, with Julia being one of those languages. Personally, I prefer this version of Julia over base Julia, just because it's easier in the eyes and the UI is more friendly and more intuitive. Julia Box also works on the go on any computer, so if you're a student, you will not have to worry about whether or not the computer you're using already has Julia pre-installed in it. So now that you know how to get Julia on your computer, we can move on to some basic coding. So this is what you're going to see when you start up Juno. Let's start off with some basic stuff. For example, creating new variables. Now if we type in this first line of code here, x equals 3, what it's going to do is it's going to create a new variable called x equal to 3, like so. Similarly, the second line of code over here, what it's going to do is it's going to create a new variable called x equal to the vector of numbers 1, 2, and 3. For some simple statistics, we can create a random vector of 10 numbers between 0 and 1. You can do this by using the rand function, like so. And this lists out the 10 numbers that we were given. If I want to know, for example, the mean of this vector of numbers, I can use the mean function. And this tells us that the mean is equal to 0.388. Similarly, if I want to know the standard deviation of these numbers, I can use the std function, which tells us that the standard deviation is equal to 0.300. But realistically, in most situations, you're going to be doing statistical analysis on a dataset that you import into Julia, instead of randomly creating numbers or manually inputting the numbers themselves. So the next step is learning how to import data files into Julia, so that you can use the datasets for analysis later on. Personally, since I have a background in R, I like to work with data frame-like structures, since that is the format that I most often see datasets in while working with R. I have a dataset called MLB 2015 data.csv that has data on MLB players in 2015 that we can use. The first step is to install a package called data frames, which is what you will need in order for Julia to work with data frames. You can see the line of code over here highlighted. This installation takes a really long time, so I won't do it live on this video. But on the off chance that you choose to use Julia Pro, it should be pre-installed regardless, so if you're using Julia Pro, you can skip this step anyways. The next step is to tell Julia to load the package with this line of code using data frames. The next step is to use the readTable function to define a new data frame, which we'll call MLB. We can do it with this line of code right over here. But before you do this, it might be useful to double check that your file is in Julia's working directory. The working directory is the place on your computer that Julia will check for the file when you use the readTable function. You can check where your working directory is right now with the pwd function. And this tells us that my current working directory is on my desktop. Now if your working directory isn't where your file is located, you can either move your file into the working directory, or you can just change where the working directory is with the cd function. For example, if I wanted to change the directory to my desktop, I would use this line of code highlighted over here. So now that we've confirmed that Julia is looking in the right place for the dataset, we can just use this line of code over here that I previously mentioned. And this will read the dataset in the Julia. We can double check whether or not the dataset was imported correctly by typing in something like this, which uses the size function to tell us the amount of rows and columns in the dataset. And this tells us that there are 134 rows with 21 columns in the dataset, which is what we would expect. We can also check that the dataset was imported correctly by looking at some summary statistics of the data by using the describe function, like so. And it seems like everything looks like we would expect if we scroll through the summary statistics of the variables. If it's necessary, there are some keyword options that you can add to the readTable function, so that Julia will look out for certain types of formatting. For example, this line of code over here will let Julia know that the data are separated by a comma, which can be useful if you're using a .txt file instead of a CSV file, or if your data are delimited by a separator that's unstandard. This next line of code over here will let Julia know that the first row in your dataset contains the first row of observations, instead of the observations starting on the second row, with the first row being a header row describing the column of variables. So these are some of the basics of using Julia. I hope that this piqued your interest enough to start picking up Julia as a new programming language. Next up in the series of videos, we're going to cover 3 things. The first is going to be hypothesis testing. Next, we're going to cover how to visualize data in the form of plots and graphs. In the last video, we'll focus more on general coding using the MLB dataset we just saw.